Hey everyone, today we will be solving this problem, reverse a linked list in groups of a given size. So basically you have to do nothing but reverse every k nodes while traversing the list. And if the last group has lesser than k nodes, then just reverse that many only. So for example, these are the nodes. Now what you have to do is, and let's say your k is given 3. So you have to create groups of size 3 like this. So this will be your first group and then this will be your third group. Now, in the end, there are only 2 nodes left. So the question suggests that if there are less than k nodes remaining in the end, then you have to reverse only them. So that is your new group. Now, how would we reverse it? So these type of questions are straightforward. You have to only manipulate the links somehow of this linked list and make sure all the links are removed or added correctly. So the only catch here is that the links that you are removing or adding, that is totally correct, and like it is not changing any behavior, or like you missed some links, you added some wrong links, or you removed the links. Just silly mistakes can happen here and there. So for example, in this case, what would be the output? So these are the groups, so this is your output. So basically these links are switched, these links are removed, and some new links are formed like this. So basically what you have to do is you have to simply traverse from left to right, and so basically we move k minus 1 times. For example, here k is 3, so I will move from 2 times, I will be at 3, so this will be your tail. Then I will remove this link, so this group is isolated now, and I will apply a reverse linked list function on it, the standard one. This way my linked list will be reversed like this. Then I will go to the next group. How can I go to the next group? I need the pointer to this node, 4 node, right? So basically when I am removing this 3 to 4 link, first I have to save this node's address somewhere, like this pointer, something like next head or something we will call it. We will save it somewhere like that, so that when this reversing is finished for this group, now next we will do is we will reverse start from here. So this next head would be your new head. Then you will do again the same thing. So first you will isolate it here, from here, and then now one more thing that you have to do here, you have to make this link. So this will be your previous head, I can say, and this will be your current tail, I can say. So basically these are some pointers that you have to save when you are traversing the linked list. And in this case, the first time you could not do this because previous head was not there. And you also observe that this 3 is actually the head of your final list that you have to return. What we can say is, if we have a previous head, then we have to do something like previous heads next will become my current tail. Otherwise, final head would be your current head that we have. We will return this final head. The only thing that's remaining is like how do we reverse a isolated linked list? Basically the standard reversing a linked list problem. So let's suppose this is your linked list 1 2 3 4 null. So what you can do is you start from here. Let's say this is your head. So basically you have to change these links in this manner, and this will be your new head. So let's say we are at this node 3. So first thing we will do is we will require the address of this node 2. So we will store it somewhere. So let's say we have it in previous. Initially, like there is no previous, so here we will create or initialize this previous as null. So for example, this one will also point to null. Also, second thing is you have to remove this link. So when you are pointing this to the previous node, this will this will automatically remove. So before pointing this to previous, what you have to do is you have to save it somewhere. So let's say it is your next head. After you have created this particular link, you have to move to this node 4. So your head will be this next head, and your previous will be this 3. So these are also some pointers that we need to change. So your previous will become head and your head will become next head. This order is also important, because when I'm doing previous equals head and then I'm changing head equals next head, if I'm already changing this head equals next head, then the value that head contains is lost. So when I do previous equals head, if I do it later than this, then it will have the new head, that is previous becomes the next head as well. Let's code it. So first let's do this while head, like we are moving from left to right, so until we reach the end we have to move k minus 1 steps ahead, right, to find the first k nodes. So we can say a struct node start tail equals move forward. I will create this from this head for k minus 1 steps. So what this function will do, this will try to move k minus 1 steps ahead from head and then save it in the tail. And if there are not that many nodes, like if k is let's say 7 but we have only 3 nodes after this head, then we will stop it at the last end, so tail will never be null. We will make sure that. So what I'm saying is, like if 1 2 3 and 4, and suppose we have to move 5 nodes ahead from 1, so first node, second node, third node, but after that there is nothing, so we will stop at 4 and this will be your tail. This is what I'm saying. So now we have this tail and this is our head, so we have to remove this link. So we will do something like tail next equals null, but again if you do it then you will not have this access to this node 4. So before doing that we will need to make sure that we store it somewhere, and this will be a new head, so I will name it as next head. So before that struct node start next head will be your tails next. And now we have isolated this group, so let's reverse this. So I will also create this function reverse list for this head. Now the list is reversed. Let's say we are at this group, we have to create this link 1 to 6. So if we have this previous head, then we need to create this link. If we do not have the previous head, like if we are at this 3, then we need to make this 3 as the final head. So we also need a previous head, right? So we will do it something like this. So outside we will initialize previous head, initially it will be null, and now we will check if previous head is here, then previous head next will be your tail to create that link, and if it is not there then the final head will be current tail. Initialize this final head as null, and then this new previous head would actually be the head. Like you see now, suppose we are at this group, so this new previous head will become 4, so this is stored in head, so that's why we did this previous head equals head. The head will become next head. Again, the ordering of these two statements is important, because here it is accessing the head, whereas here it is overwriting the head. So before overwriting we need to access it, and finally we need to return the final head. Now there are two functions that I declared here, move forward and reverse list, so also write them as well. So move forward is given head and the number of steps that need to be taken, and while also we will make sure the tail is non-null, right? It is the last node of that group, so we will stop at non-null node. So while head next is not null and steps minus minus, what we will be doing, node head becomes heads next, and whenever we are going to stop, either like we reached k minus 1 steps or there is no more node, we will stop and we will return this head. So this will be stored in tail, and also we require this head to be non-null. Head must be non-null because we want this tail to be non-null. and second the reverse list function. So what we have to do is, while there is this head like traversing from left to right, we have to change the links to previous nodes, right? So what we have to do is we have to do heads next equals previous. But when I am doing head next equals previous, so heads next is lost. Basically what I am saying is, like suppose we are at this 3 and I am doing this heads next equals 2, so because then it removes this 3 to 4 link, so the access to 4 is removed. So that is why we have to store it somewhere first. So to store it somewhere, let's say it is next head. This previous we have not declared it anywhere, so it is coming from last iteration, so we initialize it as null and then we will update this previous. So this previous becomes head and our head becomes next head. Again here you have to keep this order maintained as I discussed earlier. So yeah, that should be it. Let's compile and run. Alright, so I think I used this Java null here, so let's change it to capital null. And that should be it. So now let's come to the interview tips part. So the interview tip here would be, always try to modularize your code. Like for example here, I did not write the whole thing here. I actually created these two functions and used them. So make sure you are making different methods when it makes sense or when it makes your code look cleaner, rather than doing everything in the same function. So yeah, that's it. Hope it helped you somewhere in how to approach a problem, how to ensure adding and removing a link won't cause a problem. Please let me know in the comment section if it helped you anyhow. I need to understand if I'm even helping people or not. Also feel free to ask me any question or any doubts in the comment section. I'll be happy to answer. Thank a lot if you're still watching. Have a great day ahead. Bye bye.